Hi, Miss.
Hi, dear. How are you? Can you hear me well?
Yes.
All right. Hello, dear. Please mute your mics, okay? I'm going to start by saying this at the beginning because last time I got people out of the session and I will do the same today. I don't have any willing to waste our time. Yes, Ayman.
Miss, I have two types of magnets.
All right. Very good. Which type?
I have a horseshoe magnet.
Yeah.
A rod magnet.
And a rod magnet. Nice. Very nice. Try putting them together. Yeah. This isn't a rod. This is a bar magnet.
Okay.
Oh yeah. Muhammad, we are not in a competition. All right, guys, I will take the attendance now so that we can start. We are going to finish all the worksheets of the magnetism today, inshallah. And if we have time, we will start doing the practice worksheet, the final practice worksheet at the end of your resource pack. Let me just tell you what will happen next. Through this week, this is supposed to be our revision week. So after finishing the final practice worksheet of your resource pack, I am going to re-answer the quizzes, the two quizzes that you took during this trimester with you. I'm going to open them up and re-answer them with you because I want you to know what are your mistakes. And after finishing all of this, I will do like a revision PowerPoint for you to go through all of the 3 lessons that we took during this trimester. Okay. Of course, if you have any questions related to the lessons, you're more than welcome to ask during this week. Okay. Let me start. Adam is getting in. Alia is here. Can you even raise your hand, Alia, if you cannot use the... Yeah, she's here. She sent to me. Okay, Ayman is here. Bilal.
Yes, miss.
Okay. Adam, did you join us?
Yes.
Okay. Dana?
Yes, Miss.
Habiba?
Yes, miss.
Jaida?
Yes, Miss.
Layan?
Yes, miss.
Okay. Malik? Malik, are you there? Okay. Mu'mina? Okay. Ahmed is here. Muhammad.
Yes, miss.
Okay. Nadim is here. Omar.
Yes, miss.
Sif.
Yes, Miss.
Suhaila.
Yes, Miss.
And Tayyim just joined. Tayyim.
Yes, miss.
Okay. And by the way, guys, there will be an extra final practice worksheet that I will upload for you today on Classera with its model answer. So you can check it out today after the school day. All right, let me start. We are going now to answer correct the homework together that I gave you. Your homework was pages, I think 85, right? 85, 86, 91, and 92. Am I correct?
Yes.
All right. Let us finish those quickly because we are missing only one small part in the magnet lesson, so we need to finish it today too. Open page 85, please. Page 85. All right, here we go. So in page 85, we have a clown which is making some rings float in the air. Now we know that there is nothing magical about this. This is this whole thing is science. The lowest magnet has its north seeking pole upwards and its south seeking pole downwards, as shown in the diagram. Show the arrangement of the poles on the magnet needed for this to happen. If you want to answer, raise your hand. Yes, Ayman? Finish the whole pole, please.
Yes, miss. Okay. So this will be north at the bottom and south at the top.
North at the bottom and south at the top. Very good. Huh?
South at the bottom and north at the top.
Very good. Excellent. Thank you
Is
so
that
much.
page?
This is why they are going to repel from each other, and it will look like they are floating. They are actually, all of the magnets are repelling from each other.
Yeah, it's page what?
Miss, can I go to the toilet?
Yes, Habiba, you may. This is page 85. Now we're going to question number 2. Sarah found her little brother playing with magnets. He was banging them together. Write a safe handling rule that Sarah should tell her little brother. Of course, we did not take this part, but if any of you answered it, that would be perfect. Yes, Suhaila. I think it's something about common sense.
Yeah.
Yes, Suhaila.
To let the conductors away from the metal.
What conductors? How to deal with a magnet? What should you do with a magnet?
Miss, I need answer.
No one.
No one unmute their mic, please. I can see all of your hands raising. Suhail. Hey, Suhail, do you know how should we deal with the magnets? All right. Yes, Nadim. Of course, Suhaila, it's okay, dear. We are going to go through it today, all right? So it's fine that you don't know. It's totally fine. Yes, Nadim.
Sarah should tell her little brother to hold the magnet from the bottom.
To hold the magnet from the bottom, why?
Because if her brother holds it from the side, his hands could get, and they get attracted, his hands could get hurt, get injured.
Okay,
like
this is a point of view. All right. Yes, Layan.
There are a lot of other answers, but that's the one that came in my mind.
All right, Nadim, thank you.
He can slowly allow the magnets to come together.
Yes, if he wants to attract two magnets together or stick two magnets together, he shouldn't keep them like a little bit apart from each other, so when they leave them, they will bang against each other. No, he should slowly bring them next to each other so that they can stick or attract each other slowly without banging together. Yes, this is very good. Yes, Dana, do you have any other answers?
Put it away from electricity.
Put it away from electricity. Well, it's not necessary, but yes, okay. I would recommend this too. All right, guys, we're going to leave this until we take this part. Okay, it's totally fine. But Lyanne's answer is fine. Dana's answer is okay. Now the next question is also related to what we're going to take today, but it's also common sense. Now, her mother asked her to store or to put the magnet away. What do you advise, Sarah? This is something actually that we actually took. Do you remember the piece of metal or the piece of magnetic material that I told you about? The magnets should be stored with? Yes, yes, Ayman, yes.
It's a piece of iron. It's called a keeper, and it stores the magnet force.
Yes, so
uh,
she should put a magnetic keeper on the magnets not to lose its magnetic force, right?
Yeah.
Yes,
Yeah.
thank you, Ayman. All right. By the way, there are other things like what? Like, for example, you should not put the magnet in places that has water, or in wet places, or in humid places, because this will make the magnet lose its magnetic force. Another thing that we are going to talk about today is that you shouldn't bring it closer to your mobile phone, or any magnetic, any card that has a magnetic strip, like a credit card or a debit card, or even, do you know the cards that we open the hotel rooms with?
Oh yeah, I know.
Yes, you should not put any magnets near it, because it is going to lose its function. The card itself, it's going to lose its function. You should not put it also next to any colored TV, because sometimes the magnetic force could disrupt with the colors of the TV. This is something that have been noticed before when we put a magnet next to the colored TV. Anyway, guys, I'm going to leave this question until we take the safe handling part, and then I will get back to it again. So if you did not know how to answer it, it's totally fine. All right. Now the next one, the next page, page 86. Page 86 is really easy. You have 5 mixtures, 5 things that we, or 5 piles of things that we mixed together. And we want to know which one of those piles, or which one of those mixtures that you can actually use a magnet to separate them from each other. Okay, so you are looking, there are 3 mixtures or 3 containers which contain a magnetic material which will be separated using a magnet. Habiba, can you answer this? Did you come back, dear?
Yes.
All right, dear. So let's see which one of those we can use a magnet to separate them. You have the aluminum cans and paper. Can we use the magnet? No, because the aluminum, yes, it is a metal, but it's not a magnetic metal. So it's not going to get attracted to the metal. Yes, and the next one?
Is steel cans and plastic bottles.
Yes. Can we use a magnet here?
Yeah, just the steel will make.
Yes, I want to separate them. So yes, I want one of them to be attracted to the metals. So yes, this is going to be separated using a magnet, because the steel cans is going to get attracted to the magnet, and the plastic bottles will be left behind. This way we separated both of them from each other. Okay, the next one, Habiba, glass jars and steel lids.
Only the steel lids can be attracted to the
Yes,
magnet.
so this two is a mix that I can separate them using a magnet, because the steel lids will be attracted to the magnets. The plastic bottles and paper.
No.
No, they will not. Neither one of them will be attracted to the magnet. And the last one, iron nails and copper nails.
Yes, only iron.
Yes, only iron will be attracted to the steel. And this is why it will be separated from the copper nails. Thank you, Habib. I think it's easy. Do you understand? The rest of you, do you get it?
Yeah.
All right. Now we are going to open page 91. Page 91. All right. So in page 91, Hannah has 3 rods, A, B, and C, made from different metals. One rod is a magnet, one is made of copper, and one is made of iron. She does not know which rod is which. So we have 3 rods, A, B, and C. One is a magnet, the other is made of copper, the third one is made of iron. Okay? Each rod has a dot at one end, and we will know why when we read the questions. But let me tell you that this is to know which one is the magnet. Okay? We will understand while we are finishing answering. Hannah uses only a bar magnet to identify each rod. She puts each pole of the bar magnet next to the dotted end of each rod. Complete Hannah's observation in the table below. Write if each rod is copper, iron, or a magnet. Now, I will ask you before doing anything in the table, guys. I'm not looking at the table right now. My question is, how will the magnet, the bar magnet that Hannah is using, how will it react to the magnet? We have 3 rods. One is a magnet, one is iron, and one is the copper. How will the magnet react with the magnet, with the other magnet? It might what or what? Yes, Suhaila.
Might repel or attract.
Very good. It might repel or attract. So this will make us know which one is the magnet, right?
Yeah.
All right. Very good. Thank you, Suhaila. And how will it react with the copper rod? How will it react with the copper rod? Dana, can you tell me?
1 second.
All right. How will the magnet attract? How will the magnet react to the copper rod?
Nothing will happen.
Nothing will happen. Excellent. Nothing will happen because copper is not a magnetic material. So it is not going to get attracted to the magnet at all. All right. And the last thing is how will the magnet react to the iron rod? It is going to be attracted to it. Whether this magnet is facing the north or the south, it doesn't matter because this is a magnetic material. The iron is a magnetic material. It is not a magnet. It is not a magnet. So it doesn't matter which side is the bar magnet on. All right. Now let's see. Let's do the table together. The first one, she put the magnet on the north side, and she brought it closer to rod A. It got attracted. Okay, rod A got attracted to the bar magnet, and when she flipped the magnet so that the rod can face the south pole, it also got attracted. So rod A is what? Raise your hand if you know the answer. Yes, Nadim. Rod A is what?
Iron.
Rod A is the iron. Yes, is the iron rod because it will be attracted anyway.
It will be attracted by the south pole or the north pole.
Yes, exactly, because it's a magnetic material, so it doesn't matter. It's not a magnet, so it doesn't matter which side the bar magnet will be on. All right, thank you. The next one, when she when rod B faced the north pole, nothing happened. So what do you expect will happen when the rod B faced the south pole? Huh? What do you expect will happen? Safe.
Yes.
What do you expect will happen?
Nothing happens.
Nothing will happen. So this means that rod B is what, safe?
It's non-magnetic.
Which is? Which material is non-magnetic from the three rods? We said one is made of iron, the other is made of copper, and the third one is a magnet.
Copper.
So yes, rod B is copper. Very good. All right. Now, the last one is rod C. Rod C, when we faced the North Pole, when rod C faced the North Pole, it got attracted. So what will happen when it faces when it faces the South Pole? Huh? Yes, Taim. Taim?
Yes.
Yes, dear. So what will happen when rod C faces the South Pole of the bar magnet?
Nothing happens.
No.
Wait.
We are left with what? We know that rod A is the iron rod. We know that rod B is the copper rod. So this makes
It will attract.
It will attract from both sides. It got attracted from the North Pole, dear.
So it's
Okay, let me just answer my question. We know that rod A is the iron rod. We know that rod B is the copper rod. Rod C is what?
magnet.
Is a magnet. Okay, so I'm going to write here that this one is the magnet. If it got attracted from one side, so what will happen from the other side?
It will repel.
It will repel. Thank you so much. Okay, so it will repel when rod C faces the South Pole, and this is because rod C is a magnet. Okay, all right. Now I need you to open the last page, page 92. Muhammad, is there something wrong? Are you playing in the chat? This is one morning, Muhammad, huh? Okay. Now let's go to the next page, page 92. Page 92, you have a word bank, and they want you to complete or to assign each word to the right sentence. Okay, to assign each word to the right sentence. Number one is how the North Pole of one magnet and the South Pole of another magnet react to each other. How the North Pole of one magnet and the South Pole of another magnet react to each other. What will happen when you face two opposite poles to each other? What will happen when you... Yes, Habiba?
It will attract.
It will attract, exactly. So whether you can write the word, the whole word, or you can write only the letter, okay? If you wrote only the letter, it's totally fine. All right, so it is attract. No, Dana. Dana, they will not repel. They will not repel because the South Pole is facing the North Pole. So those are two opposite poles facing each other. So of course they will attract. Okay, only the similar poles repel.
I got confused and I read another question.
It's fine. It's fine. The second question is, Dana, you can answer the second. Yes, how the North poles or South poles of two magnets react to each other. So this means that we're talking about the North poles of two different magnets or the South poles of two different magnets. How will they react to each other? They will
repel.
Repel, exactly. So the similar poles
Did you call me?
repel. When? Now? No, I didn't call you. Okay, number 3, where the force of a magnet is strongest. Do you remember when we talked about the magnetic field and we said that there are specific parts, specific part that the magnet will be very strong at, the magnet force will be strong at. Which part of the magnet? Yes, Ayman.
Yes, Miss. It is called the magnet field.
The magnetic field, yes, it is where the magnet is the strongest. My question is which part of the magnet will the force will be the strongest? Is it
the poles?
The poles, exactly. The poles. So this is the answer, pole. Okay, this is the answer. The next one is what you're trying to say, Ayman. The area of magnetic force around the magnet. The area of magnetic force around the magnet, this is what we call magnetic field. Sorry, magnetic field. Okay, this is the area of magnetic force around the magnet. But which part of the magnet that has the strongest magnetic force? The two poles, not the center and not in the middle, it's on the poles. All right, the last one, a magnet created by an electric current. This is the last part of the last session. The last part of the last session, and I think Ayman watched the video, right, Ayman? How to make what?
Yes, Miss.
How to make what?
To make magnet.
And yes, we call this what?
Miss, someone talked with you. I can't hear you.
Can you hear me now?
Yeah.
Yes. So when we make a magnet at home, we call this what?
Natural magnet?
No, natural magnet is the one that we bring from the nature. The one that you do at home, the one that you watched its video.
Yeah.
From the electricity.
It's called the electromagnet.
Electromagnet. Thank you so much. Electromagnet.
Miss, it says
or electromagnetic.
Yeah.
It's fine. Okay. So
Miss, the words are more than the questions.
Is that a problem?
That's to confuse you.
Mute your mics, guys. All right. So we are done with correcting the. We are done with correcting the homework. Now we are going to finish the last parts of the magnet lesson. So let me just open the PowerPoint.
Miss, there's a worksheet next to it. Page 93.
Yes, this is the one that you need to read your textbook. You need to read the closer look book in order to answer it. But we are going to answer it together, but not now.
Okay.
Yes, Omar, it's fine. We have 10 minutes and we have another session. Thank you so much for being our alarm. This is lovely. Anyway, so we are going to take the last part of our lesson, and this last part where we are going to talk about, I'm just going to repeat the electromagnetic or the electromagnet again, and then we're going to move on with the very last part. Okay, so here we go. I told you, or I asked you, if you don't have a natural magnet, can you make one at home? Yes, you can. Using those materials, you need a nail, an iron nail, or an iron or a steel nail. You need a coil. A coil means copper wire, and a battery. and you also need some pins or stapler pins to test your electromagnet. Okay, so what are you going to do? This is what you're going to do. You're going to bring the nail, and you're going to surround the nail or coil the copper wire around the nail this way, and then you're going to connect the wire to the two sides of the battery. This way you made what we call an electromagnet. What's the meaning of an electromagnet? An electromagnet is a magnet that you made by using electricity. This is because, as I told you in the last session, scientists discovered that any electric current, and of course you should have been remembered the word electric current from the electricity lesson that we took in the previous trimester. The electric current, they discovered that all electric currents have a magnetic field, and this is why you can make a magnet. You can make a magnet at your home using electricity. All right. So this is what we call an electromagnet, because we made a magnet out of electricity. Okay. Now, how can we use the electromagnet, guys? We can use it to play with it at home, but actually some factories and industrial premises, they started to use this electromagnets to on a large scale, on a very large scale, as you can see. So how is that? As you can see, this yellow thing, this is actually a giant electromagnet. Okay, it is made of a very large piece of iron or steel, and they surrounded it by a very huge copper wire, and they connected it to an electricity source. This way they made a massive or a very big electromagnet. And how or why do they use this type of magnets? They use it to separate the metal scrappage from the rest of any other materials. Like what? Like, for example, as you can see here, this is like a place where they throw all the garbage in. Now I want to separate the magnetic materials from the non-magnetic materials. So I use what? I use this giant electromagnet to separate them from each other. Another thing is that if you have like a garage of old cars and you need to move the cars from one place to another because those cars are not working anymore, so it will be very hard that some workers come to carry all the cars to move it from one place to another. This is not practical. So this is why they use the electromagnet, so that Nadim stop using filters. Why? So that they can attract the car to the electromagnet and move it from one place to another without any effort. Okay, so this is one thing they do. They move the vehicles. And the other thing, as I told you, is that if you have a lot of garbage or a lot of unneeded materials and you want to recycle some of the magnetic metals in it, so this is why we use electromagnets to remove any magnetic materials from a pile of garbage. This way we can separate them and use the magnetic materials again. All right. So now, do you understand the electromagnet, guys? Is there anything that you don't get it?
No, it's really easy.
All right. Now, how to safe handle the magnets? How can we use the magnets without getting hurt, and how can we store them? This is afterwards. Now, the main thing that we are very concerned about is that the magnets, they can break easily. If you bang them together or against anything hard, they can start to break into very small parts that could get into your eye, for example, and this is very bad because this kind of materials can hurt your body and make a very good damage to it. So this is why it's very important that once, as Liane said, if you want to bring two magnets together, you don't bang them against each other. You have to bring them closer to each other slowly. And of course, you should not bang them, even if you don't want to attract them to each other. You should not keep banging them against each other, because they will break into small pieces and they will fly off and maybe hurt your eye. You have to wear safety goggles if you're going to make some experiments using the magnets, because of the same reason. You don't want to risk any small pieces coming into your eye. Of course, as I told you, don't bang them against each other, and do not bang them against other hard stuff. Like, don't drop the magnets to the floor really hard. Not only will they break, it will also affect their magnetic force. Wear protective gloves and take care that any magnetic materials around food and drinking water might affect it, because you have some magnetic radiation coming out of the magnets, which could affect the food and drinking water. Now, how to store a magnet? You have to store the magnet. You don't have to put it near any, as I told you, any videotapes or any CDs or any audio tapes. Parts of those of the information inside the CDs or the videotapes or the audio tapes will be erased because of the magnetic radiation or the magnetic force that comes out of the magnet. Do not put them next to credit cards or debit cards or any cards that have this magnetic strip in it, because it's going to lose its function. Don't use the magnets near the mobile phones and interactive whiteboards or computers. It will affect its efficiency. And as I told you, do not put them next to TV screens or computer monitors, because the screen colors will be affected by the magnetic force. So, and the last thing, don't put them in wet places or moist places, like places where you know that might be affected by rainwater or dust or anything, because this way it is going to affect or lose its magnetic force. All right, guys, is it clear?
Yes.
All right. Now we can get back to page 85. Did we do page 83 and 84? No, we didn't. We did not. Okay. All right. Let's do first question number 2 in page 85, and then we can do 83 and 84. I think I'm going to end the session. Yes, I'm going to end the session and I will start the new one, guys. All right. I'll see you in a bit.